Hello everyone and welcome to our third part of water treatment. In first part we have seen what is impurity and types of impurity present into the hard water. And second part we have seen the types of hardness. Now today's part we will see how the hard water it is softened. There are the three methods for the softening the hard water. First, ion exchange method, soda lime process, and that is zeolite process. In today's part, we are going to see the ion exchange method or ion exchange process. Ion exchange method. Ion exchange method or ion exchange process. This ion exchange process, what happens? Here exchange of ions takes place. That ions may be in the form of cations or maybe in the form of anions. So this method it is also known as ion exchange method is also known as demineralization. Demineralization, or it is also known as deionization. Deionization. Okay. Actually, what happens in this process? We will see what is means D. D means to remove. Just example we have taken of dehydration means removal of water molecule. Dehalogenation, removal of halogen. Decarboxylation means removal of carbon dioxide. In the same way, demineralization means removal of minerals from the hard water. That's why it is known as demineralization. And deionization means removal of ions from the water, that is known as deionization. Okay, for the MCQs the question should be asked on this part, that is ion exchange method is also known as dash, means the ion exchange method is also known as, it may be demineralization or it may be the deionization. Okay, in ion exchangers methods, that is ion exchanger resins are used for softening the hard water. Now we will see what is resin. Resin, it is nothing but it is a insoluble, porous, natural or synthetic polymer which is having ionizable functional group, that is known as resins. These resins are also known as ion exchangers. Okay, there are the two types of ion exchanger resins. First, it is the cation exchanger resin. Cation exchanger, cation exchanger resin. Now we will see the definition of cation exchanger resins. The resins which are having capability of to exchange the cations, that may be the cations that may be calcium, magnesium or maybe sodium. They can exchange the cations present into the hard water by H plus ions, by H plus ion present into the water. Okay, by H plus ions, that is known as cation exchanger resin. Okay, and second one, it is the anion exchanger resin. Anion exchanger resin. The resin which is having capability to exchange the anions present into the hard water with OH minus ions. That anions we can take, that is Cl minus, SO4 minus, HCO3 minus. These are the anions. They can be exchanged by the hydroxyl ions, that is OH minus ion from the resins. Means they have the capability to exchange the anions from water with OH minus ions. That is known as anion exchanger resin. These cation exchanger resins are denoted by RH2 and anion exchanger resins are denoted by ROH2. Okay, ROH2. Thus, if the hard water it is allowed to pass through these resins, that is cation exchanger resin and anion exchanger resins, in that water becomes free from cations as well as anions. Now we will see how the ion exchange method actually works. This ion exchange method consists of 3 cylindrical vessels. Okay. In first cylindrical vessel, cation exchanger resins are placed. This is the cation exchanger resin. It is placed there. That's why it is known as cation exchanger. Okay. In second, it is anion exchanger resins are placed. It is known as anion exchangers. Anion exchanger. And third part, it is a degasifier. It is a degasifier. Again, D means to remove. Means here the removal of gases takes place. That's why this cylinder is known as a degasifier. Now we will see how the cation exchanger resin it is going to be work. Whenever the hard water, that is impure water, is passed through this cation exchanger resin, here what happens? Here exchange of cation ions takes place within this cylinder. Here the H plus ions from the resin get exchanged with the calcium and magnesium present into the hard water. Now we will see the cation exchanger resins in the form of reactions. Suppose first of all I will take the cation exchanger resin. It is denoted by RH2. Okay. Whenever these resins reacts with that is calcium present into the hard water. So I have taken the example of calcium. Okay. RH2. Here exchange of ions takes place. Means these H plus ions from the resin are going to exchange with the hard calcium present into the hard water. Now it becomes RCa plus 2H plus. Okay. Means here exchange of these ions are taken place within that. Suppose we are taking another example, that is RH2 plus, suppose I have taken the example of magnesium, Mg2 plus. Okay. Then there is a formation of Rmg plus, that is 2H plus. Means here the exchange of ions takes place. That's why it is known as a cation exchanger resin, where R it is the resin and this is the H plus ions present into the resin and this is the magnesium ions present into the hard water. Means what happened? The water which comes from this cation exchanger resin, it becomes only free from the calciums or magnesium, means that is cations present into the water. And in case what happens, the H plus ions are released from these resins. These H plus ions are released from the resins. After this means this water becomes cation free, but remaining, that is anions are present into that water. But that water anions are going to react with the released H plus ions. That anions maybe that is Cl minus, SO4 minus, HCO3 minus. These ions are going to react with the hydrogen released from that resin, and due to that water becomes acidic. Means this H plus whenever combines with this Cl, there is the formation of HCl. Whenever the H plus ions combines with SO4, it forms H2SO4. Again, whenever that released hydrogen from resin reacts with this anion, that is HCO3, there is the formation of H2CO3, that is carbonic acid it is formed. Means the water which is released from that first cylinder, it is free from cation. But when they react with H plus ions that from resins and the anions present into that water, the water becomes acidic. Okay, and that becomes more harmful. So there is necessary to remove the anions also from the water. That's why this cation free water, it is passed to the second cylinder, that is known as a second exchanger, that is anion exchanger cylinder. Okay, or anion exchanger. Okay, this water becomes acidic. This acidic water, it is passed through this and it flows through the anion exchanger resins. In this what happens? Here again exchange of anions takes place here. Means here that is Cl minus, SO4 minus, that all anions are going to absorb by this resin, that is anion exchanger resins. These all are going to absorb on that, and OH minus ions are going to release from that resin. Okay, in first case what happened? Only cations are going to be released along with the H plus ions with the resin, from the resin. And in second cylinder, anions are going to be absorbed on the surface of that resin, and OH minus ions are released from the second cylinder. Okay, means the water becomes, in this first and second cylinder, the water which is obtained, it is free from cations as well as anions. Okay, means this is the demineralized, deionized water. This is also known as distilled water. Okay, now we'll see how the that is anion exchanger resins reactions it is going to be takes place. We'll see the reaction of anion exchanger resin. In the reaction form, anion exchanger resin in the form of reaction, that is, we already seen that anion exchanger resins are denoted by ROH2. ROH2. Whenever cation free water comes along, passes through the anion exchanger, that is, it contains the, suppose we have taken the twice HCl. Okay, because it is the acidic water, that's why we have taken the twice HCl. It forms there RCl2 plus twice H2O. Okay, means here water, we are going to obtain here water. Okay, and these resins are accumulated or absorbed on the surface of second resin, that is anion exchanger resin. We will take the second example of anion exchanger resin, that is the ROH2. It is the anion exchanger resins. Whenever it reacts with the H2SO4, means the released H plus ions from the resin and SO4 from the anions, that is hard water. Okay, that is H2SO4, because this is the acidic water which is passes from the cation exchanger resin, and there is a formation of RSO4 plus twice H2O. Okay, here the exchange of ions takes place within this. This is the exchange method for the anion exchanger resins. Means the water which goes through the cation exchanger resin and anion exchanger resins, they are now free from cations and anions. But though this is the distilled water, but still this distilled water contains the gases which are dissolved within that water. That we have to remove. That's why this demineralized water again passes through the third cylinder, that is known as a degasifier. And this degasifier, it is connected to the steam jacket, from where we are going to provide the temperature to this degasifier. At low pressure and high temperature, the carbon dioxide is given out from this. And the water which is released from that, this water, it is a distilled water which is free from both, that is, it is a cation free, anion free as well as gas free water. The H plus ions from obtained by the cation exchanger resin, OH minus ion it is obtained from the anion exchanger resin, and gases it is already removed from that, and there is a formation of pure form of water from the ion exchange method. Okay, from this method we will get cation free, anion free water as well, anion free water, and this method is also applicable for acidic water and alkaline water also. And by this method we will get only 2% of hardness of water. These are the advantages of ion exchange process. Okay, but what is the disadvantage of this ion exchange method? There are only two drawbacks or disadvantages of this ion exchange process, because this method becomes expensive. That is, this equipment, it is expensive, and these resins are also, because we have to regenerate again and again this that is resins, and that becomes costly. Why there is need to regenerate that resins? Because what happens, whenever after using it is long term. Here H plus ions and OH minus ions from the resins are get exhausted. Okay, that's why there is need to regenerate that cation exchanger resin and anion exchanger resin. So this cation exchanger resin, it is regenerated by adding HCl, and anion exchanger resins, it is regenerated by adding NaOH to the, that is anion exchanger regenerator. Okay, from this we are going to add the NaOH. Okay, that's why it becomes quite expensive, this technique of ion exchange method. And turbid water causes the decrease in the efficiency of cation. This is ion exchange method. Okay, these are the two drawbacks of this cation exchanger, ion exchanger resins. But more than that, it is more useful for the softening the hard water, because only 2% of 2 ppm, that is parts per million of hardness, it is remained within that. That's why it is the best method for the purification of hard water. Okay, thank you. In the next we will see the zeolite process.